In this section, we'll review how to solve absolute value equations and inequalities. So this is an example of an absolute value equation. Absolute value of 2x plus 4 is equal to 6. So an absolute value equation always has two solutions. And the way we find them is by, in general, making sure that the absolute value sign is on one side of the equal sign by itself. And then when we ask ourselves what numbers have an absolute value equal to 6, there are two. Either the number is -6 or the number is +6. Both -6 and +6 have an absolute value equal to 6. And so all we have to do is solve these equations. So we solve these equations by subtracting 4 and dividing by 2. So our first solution is x is equal to -5, or our second solution, which we're going to get in exactly the same way, x is equal to 1. So I'm going to write down the steps that we followed for that process. So in general, what we're going to do is we're going to set up two equations. To solve. After we make sure first we isolate, or in other words, get by itself, the absolute value sign on one side of the equation. And then once you have your two equations set up to solve, then you just solve, and that's all you have to do. Here, we'll do two more examples. So first step is to get the absolute value sign by itself. So we have the absolute value of 3x plus 2 is equal to 5. And then there are two numbers whose absolute value is equal to 5. One number whose absolute value is equal to 5 is -5. And the other number whose absolute value is equal to 5 is 5. And then once you have your equation set up, all you have to do is solve. So I'll do that by subtracting 2 and dividing by 3. So one solution is -7/3, and a second solution would be x is equal to 1. So our two solutions are x is equal to -7/3 or x is equal to 1. Let's do one more example. We'll get the absolute value sign by itself. Absolute value of 2x plus 5 is equal to -3. And now we have to stop and be thoughtful. Up until this part here, we've always said, oh, and there's two numbers whose absolute value, for example, in the last example, was equal to 5. But now we have something that's different. We have an absolute value equal to -3. And can an absolute value ever be a negative? And the answer to that is no. Absolute value is always positive. And so what this tells us is that this equation has no solution, because there is no value that we can find for x that will give us an absolute value that's negative. And that's all there is to solving absolute value equations. Now, you can also solve them graphically, and so you might take a moment on Desmos to graph the last two equations, but when you're solving an absolute value equation graphically, this is what you're looking for. Remember that absolute value equations have a V shape. And so let's take a look at our last example here that had a solution. So our last example here, our two solutions were x was equal to -7/3 and x is equal to 1. These were the two answers that we got when we solved the absolute value equation, when we solved this absolute value equation. So if you take a moment on Desmos and graph this equation, what you're going to find is that you're going to get a V-shaped graph, and it's going to cross the x-axis. In other words, this is where your function value is equal to 0 at -7/3 and at 1. What you'll find out about this last one that had no solution was that this V-shape is never going to cross the x-axis. I'm not sure where the vertex is. We could figure out where the vertex is. It's been shifted left 5 units and up 6 units, and it's been probably squished a little as well. But if we were to graph that, so it's been shifted from 0, 0, left 5, and up 6, you have a V shape like this. And so notice that this V is never going to cross the y-axis, and so it's never going to have any solutions. So I'll let you explore this last one by yourself if you'd like. But if you explore solving absolute value equations by graphing, what you're looking for is where the V crosses the x-axis, if at all. And if it never crosses the x-axis, then it has no solution. Okay, I think it's time for you to try a couple. Now let's go on to solving absolute value inequalities. So here's an example of an inequality. The absolute value of 2x plus 1 is less than 5. So to solve an absolute value inequality, the first thing you want to do is draw a graph using the definition of absolute value. And the geometric definition of absolute value is distance from 0. Then you're going to use this graph to set up two inequalities to solve, and then graph your final solution and write it using interval notation. So what do we mean by drawing a graph using the definition of absolute value? Okay, so this says the absolute value of an expression is less than 5. In other words, we're going to draw a graph of all the points less than 5 units from 0. So let's take a look at what that's going to look like. So on a number line, here's 0, here's 5, here's -5. The numbers which are less than 5 units away from 0 are all the numbers in here. So that's drawing a graph using the definition of absolute value. And now we're going to use our graph to set up two inequalities. One inequality is going to involve the number -5, and the other inequality is going to involve the number +5. So, what can we say about these numbers compared to -5? We can see that these numbers are greater than -5. So one inequality is 2x plus 1 is greater than -5. And let's take a look at the other one. What can we say about these numbers relative to 5? Relative to 5, these numbers, 2x plus 1, are less than 5. That's setting up two inequalities to solve. Now we're just going to solve these two inequalities. So we'll subtract 1 from both sides, divide by 2. So we'll have one part of our solution is x is greater than -3. And solving this one in the same way, we have x is greater than -3 and less than 2. So we can graph our final solution. Here's -3, here is 2. And notice that's why it's helpful to have the original graph, because our solution graph is going to have the same basic shape as our original graph. And to write this using interval notation, it's the interval that goes from 3 and ends at 2. Using open circles because we don't have an equal sign in our inequality. Let's take a look at another example. 2 times the absolute value of x plus 4 is greater than 10. So the first thing we're going to do is we're going to get our absolute value sign by itself by dividing both sides of this inequality by 2, giving us the absolute value of x plus 4 is greater than or equal to 5. Next thing we're going to do is we're going to draw a graph on a number line using the definition of absolute value. So here's 0, here's 5, here's negative 5. We want to graph the points that are more than, greater than 5 units from 0. And you'll see that those come in 2 parts. Here on the left, numbers that are less than negative 5, and here on the right, numbers that are greater than or equal to 5. And now what we're going to do is we're going to write 2 inequalities to solve. This first one, how are these values related to negative 5? These values, x plus 4, are less than negative 5 or equal to negative 5. Or they could be on the right side of the graph. These values, x plus 4, could be greater than or equal to positive 5. And so if we subtract 4 and solve, here we have x is less than or equal to negative 9. And over here, if we do the same thing, we have x is greater than or equal to 1. If we were to graph our solution, here we have negative 9, here we have 1. And the nice thing about having done our original graph is our solution graph will have the same basic shape. Now this is going to come in 2 regions. So if we write this in interval notation, it starts at negative infinity and goes to negative 9, closed bracket because we have an equal sign here. Or it could fall on the right-hand side, which starts at positive 1 and goes to infinity. One last example. Here we want to get the absolute value sign by itself. We will start by subtracting 3 from both sides. And now we have to divide both sides by negative 2. And this is a moment to review something really important from algebra. Whenever you multiply or divide both sides of an inequality by a negative sign, you have to reverse the inequality sign. So we're now going to have absolute value of x plus 1, reverse this sign, is greater than negative 2 divided by negative 2 is 1. And then we would continue solving just like before. So we would have a graph. We want the numbers that are more than 1 unit from the origin. The numbers which are more than 1 unit from the origin either are here on the left or here on the right. And then you would go ahead and set up 2 inequalities. The values here are less than negative 1, or the values here are greater than 1. You would continue solving, you could graph your answer, and write it in interval notation, just like before. All right, time for you to try some.